Okay, sine of 60 is root 3 over 2. Cosine 60 is 1/2. Sine of 30 is 1/2. Cosine of 30 is root 3 over 2. Okay, there's flipped. Because why? Because if we're using this angle 60, then what's opposite? It's root 3 over 2. If we're using angle 30, what's opposite? It's 1/2. Okay? If we're using 60, what's adjacent? It's 1/2. If we're using 60, what's or if we're using 30, what's adjacent? It's root 3 over 2, right? So it's just because depending on what angle we use, that changes which is adjacent, which is opposite. So it ends up flipping. Okay. So 30-69 triangles always have a ratio of 1 to 1/2 to root 3 over 2, where the hypotenuse is 1. Okay, that'll always be the ratio. So again, for another example, if the hypotenuse is 5, one length will be 5/2, one will be 5 root 3 over 2. Okay, simple, simple. All right, so now let's talk about trees.
Yeah.
And the sun. And the sun shining on a tree. And then the sun shining on a human. So this is a real way you can get a good approximation of the height of a tree. So if the sun is casting a shadow on a tree, all you have to do is stand on the shadow and then walk until your head starts to appear. And now you see like your shadow head, right? And then you walk back until your head shadow is lined up with the top of the tree shadow, right? And then you'll end up with this picture. So the idea is that the sun will go right over and cast a shadow on the person, but that person's shadow is going to perfectly line up with the tree shadow. Okay? So if the human has a height of 6, and the human has a shadow length of 8, which you'd also have to measure in order to do this, okay? We don't know the height of the tree, but we can also measure the tree shadow length of 30, right? And since we know how similar right triangles work, clearly the triangle formed by the human, the sun, and the shadow has the same angles as the triangle formed by the tree, the shadow, and the sun, right? So these are similar triangles. So we should be able to calculate the height of the tree now. I'm going to try to do it, see if you remember how.
Yes.
And then I will put up steps in a sec. The ratio of the height to the shadow needs to be the same as the height to the shadow. Human height to shadow needs to be the same as tree height to shadow. So I have 6 over 8 needs to equal x over 30. 6 over 8 needs to equal x over 30. So then I get 180 equals 8x. And then I can divide by 8 on both sides. And that's going to be like 22.5. Yeah. So then the height of the tree is 22.5 feet. Just heads up, I'm filming for the lovely juniors, so there's a camera.
Oh, that's exciting.
Just so you,
You
yeah.
don't want me to dance?
You can dance, yeah. Dance sounds great. Great. So look at that. With basic math, we've figured out the height of the tree is 22.5 feet just by measuring shadows and using the properties of similar triangles. Okay. So we have 30 feet, 8 feet, 6 feet. What's x? X has to be 22.5. Okay. Simple. Okay, just reviewing all the stuff we know about right triangles. All right. Here's another similar triangles example. So if we have that both of these right triangles have reference angles of 56 and 34 degrees, all right, and we know that the base of one triangle is 13.42, the hypotenuse is 24, and we know that the hypotenuse of this one's 5, and we want to figure out what that base is, we just set up our ratio or our similar ratios, and then we can solve for x from there. Okay, easy peasy. Lemon squeezy. Don't want to spend too much time on this. Okay. We set up the ratio. Okay, cross multiply, solve for x. X is 2.8. Okay. We know this has to be true because all right triangles with the same angles have to have similar, or have to have the same side ratios, right? That's why we talk about sine, cosine, and tangents, because we know that's always going to be true. We'll do some math using that. Okay. So last thing, if you know the hypotenuse in one angle, you should be able to find the other sides, right? All you need to know is the hypotenuse in an angle to find the rest of the sides. Okay. Again, should be a review from last year. Okay, so here's 64. What's opposite 64? Which side is opposite 64? Y. What's the hypotenuse? 24. So sine of 64 has to equal y over 24, right? So what's y? Y is 24 sine 64. Okay. What about x? How can I get x? Okay, well x is, what kind of side is x compared to the angle? It's the adjacent, right? So cosine 64 is going to be x over 24. And then boom, x is 24 cosine 64. Okay, go into your calculator, calculator magic, hit enter, you get an actual decimal approximation. Okay, all good? All right, and then when would we use tangent is a good question. When would I have to use tangent? What kind of information do I need to know? So let's, okay, so look, here's our angle. Here's 64, okay? When would I want to use tangent? Yeah, I don't care about the hypotenuse with tangent, right? Because tangent's opposite over adjacent. So if you know the adjacent side and you don't know the opposite side, you could use tangents. Or if you know the opposite side and you don't know the adjacent side, you would use tangent, right? Does that make sense? So here's an example of that. Okay. And I can also solve for the hypotenuse now, right? So let's say I have the adjacent side, angle 64. So cosine of 64 is going to tell me adjacent over hypotenuse, right? And now I can solve for the hypotenuse. Or tangent 64 is going to tell me opposite over adjacent, and now I can solve for the opposite side. Okay, notice what happens here when your variable ends up in the denominator, because the hypotenuse, this is adjacent over hypotenuse, we don't know hypotenuse, right? We end up with x is 12 over cosine 64. So these two flip. Why does that make sense algebraically? What are we doing? Yeah.
Multiply by x, divide by cosine 64.
Yeah, it's all, multiply x over, divide by cosine 64. So we have cosine 64 equals 12 over x. Okay, multiply x over. So we get x times cosine 64 equals 12. And now we're just going to divide by cosine 64. I would never expect you to show all those steps every time, all right? Because once you do this enough, you just realize those are flipping, right? So you just flip them. Okay, cool. So we just kind of zoom through that because this is like our basic review of all things right triangles, right? But I need to make sure that went okay. So first of all, if you want more, there's some great Khan articles that you can review. So you can just go to our Team Drive, find the lesson, read those 3 links. Covers pretty much everything we just covered, including, and it also introduces next parts of the unit, but that's totally optional, just extra resources if you need them. Let's go to boards so that we can make sure that went okay. Right. There's not that many of you in here, so let's just do boards only. We don't need to use Windows today.
Can we erase this?
All right.
Yeah, that's fine.
I got this board. This one's fine. No, I'm calling no board space. You talking about right
And JH, I overheard you talking about the Kobe Bryant thing, and it was like, it was completely wanting for me yesterday, and I don't even know. So I don't
No, I know,
I'm like,
it's like, it's on the same level as like iconic musicians.
Right,
knives,
right,
like
right,
that,
right. It's just
Yeah,
sad.
right, for sure. Right. All right, first question. Okay, draw a right triangle.
Yes, sir.
Just a triangle with a right angle.
What color?
Color, insignificant. Use your favorite color. Or if you could use your least favorite color if you want your enemy to look at it and be upset. Okay, we'll make it a 35-degree reference angle. Okay, and then we'll say that the adjacent side is equal to 12. And you need to solve for the hypotenuse and the opposite side.
Obviously, we need calculation.
You don't have to actually calculate. You can just leave it as like 12 times sine 33 or whatever like that, right? So you don't actually have to come up with a decimal. So find the opposite side and the hypotenuse given that information. Yeah, it's just like the first day of trigonometry, and this was an easy review lesson that I would think would be okay to follow on a video.
Yeah.
So, yeah, just
I don't
good.
even know how we're all human communication.
Yeah. Yeah, no, I know. It's great.
I just thought I'd ask. I come in during Wednesday, so I'm trying to come in and just get an idea of what teachers are doing on Mondays
Yeah.
when we have these abbreviated periods.
Right, yeah. No,
So,
no, yeah.
thank you.
No,
Yeah.
I hope it ends up being productive.
Yeah. Well, it
Um,
looks fancy. I think the students should get some points for fancy looking.
fancy looking.
algebraic
and it-
things.
in a second here, I'm going to have them rotate a couple spots and check some work.
Nice.
So make sure your work is nice and clear for somebody else to review. Okay. No matter how far you got, you're going to move 2 spots this way. Okay, move 2 spots this way to somebody else's work. And then you're going to see what they did and review what they did. Okay?
Well, you know that cosine is opposite.
Try again. Cosine's what?
Or sine is opposite.
Yeah.
Cosine is adjacent.
Okay, so review the work of the person here.
So you just know,
See how they
just
did?
solve it like
Did
that.
they do what you did?
I appreciate you
Yes.
wrestling that out
Yes.
for me.
They did what you did? Did they do what you did, Lucas? Any differences?
No,
What happened
they
here?
did the same thing.
I did it wrong, Mr. Robert.
Actually, wait.
Well, no, but you understand now,
I
though?
was supposed to flip the yeah.
So, but you understand now, right? Yeah, because you multiply and over then divide, right? Okay. Are you good? So they did the same thing here, right?
It was on
Okay,
its way to
so we
being
flip these because we multiply y over and then divide by cosine 35, right? So it ends up being 12 over cosine 35, right? Okay. All right, so hopefully if you had any kind of small mistake, you can recognize that now, and we can try again. All right, so let me give you another triangle. You can erase the work wherever you are. So let me be clear. It should have been y equals 12 tangent 35, and then x equals 12 divided by cosine 35. Okay. So let's try another one. Okay, another right triangle. Another right triangle. We'll make the base angle equal to 65 degrees. Okay, that base reference angle 65 degrees. Okay, and then give it an opposite side of 20. And solve for the other sides. So this is the kind of thing that like Liz would have done extensively, and whoever they have for proof geometry would have done extensively. So it's just like, let's just review this really quick and make sure we're good on it.
Because it's another way to check how they went.
Right.
I don't have to just.
Yeah.
Which you do well.
Okay. Right. It's easier with a small group. When we have like our groups of like 32, it's like, I mean, well, but yeah.
It's a small limit today.